I think this is where things start to get a bit tricky in electricity, because we're going to look at potential difference, which is a bit of an odd quantity. Not only is it the ratio of the work done to the charge, but it's also the difference. We're looking at the difference between the potential in different parts of the circuit. Now, through this lesson video, we're going to break this down. We're going to go through the theory so that we can understand what the potential difference is, how we can use it when we're talking about cells, and how we can use it when we're talking about components in the circuit. As I said, it can be tricky, so pay attention, and if necessary, watch this twice. To add further complexity, right at the start here, there are two types of potential difference. There is the one where energy is put into the circuit, the potential difference of the power supply, which we call the EMF, electromotive force, and the one where energy leaves the circuit in a lamp or resistor or something, which we simply call potential difference. Before we go too far, let's check what potential difference actually is. Let's start with an analogy. Let's start with an apple, like Newton did discovering gravity. We'll start with this, because up the tree, the apple has gravitational potential energy. It has a form of potential energy, because it has the potential to fall down. In fact, if we just cut it off the tree, it will fall. That's potential energy. When the apple is on the ground, it will just stay there. It has no potential to move anywhere. If we look at a different apple in that same tree, that apple has potential. This one on the floor has none. The potential is different. There is a potential difference. And that basically is all we mean by potential difference. Looking at the apples in two places, the apples have a difference in their potential to move, a difference in their potential to do work. In case you're wondering, by the way, in A-level we really will talk about gravity like this, potential and all. But for GCSE, let's go back to the circuit. We have some charge here, and it just left the cell. It will go round the circuit to the lamp, and because it has some potential, which it got from the cell, the light will glow. The charge has the potential to light up a lamp. After the charge has gone through the lamp, it has lost its potential. It was all spent in the lamp, and we've got a basic rule that by the time the charge gets back to the cell, it will have lost all of its potential. So the charge spent all of its potential in the lamp, so we can say that the charge had potential here, but no potential here. The potential in these two places is different. There is a potential difference. And that is what potential difference is. It's the difference in potential between 2 points in the circuit. And that's why, to measure potential difference, we put one probe here and another probe here. We put the measurer here, and that's the voltmeter. We connect the voltmeter across the component we want to measure because we want to know the difference in potential before and after the component. So we are measuring something to do with energy, but sadly we can't do that directly. The potential we are measuring is the energy per unit charge, so the potential difference is also the energy per unit charge, or more correctly, the work done per unit charge, since work done is the change in energy. So the potential difference is the work done per unit charge. V equals W over Q. And if we're talking about a power supply where the potential to do work is increasing, then we say that the EMF equals W over Q. If we are going to measure potential difference, we're looking at the potential in two different places. So we need two probes, two connectors, which we place across the component. So we can measure potential before it goes into the component, measure potential after, and that will give us the potential difference. Let's finish by looking at a circuit. We'll start with a parallel circuit first this time. Let's say that the power supply, the cell in this case, is providing every unit of charge with 5 joules of energy. 5 joules per unit charge is 5 volts of potential difference, which we call 5 volts EMF since this is a cell. 4 charges go round the circuit and each one has 5 joules of energy. At this junction, 2 charges go this way and 2 go this way. How many joules of energy has each charge got now? Yes, they each have 5 still. There's not been any change. As these charges go through the lamp, they give up all their energy, so the potential drops to 0. The potential difference is 5 minus 0, so 5 volts. Similarly, as these charges go through the other lamp, they give up all their energy, so the potential drops to 0. The potential difference is 5 minus 0, so 5 volts. We have a cell and 2 branches in the circuit, and in the cell the EMF is 5 volts, and in both branches the potential difference is 5 volts. The EMF and the potential difference in the branches is the same in a parallel circuit. Let's label them E, V1 and V2, and so E equals V1 equals V2. What about a series circuit? Let's draw one here with 2 lamps in series with a cell. Again, the cell will provide 5 joules to each unit of charge, so the EMF is 5 volts. This time in a series circuit, both lamps will light up, which means they must both get energy. The 2 lamps can't both get 5 joules of energy from the charge because the charge doesn't have enough. It only has a total of 5. So instead, let's say the first lamp gets 2.5 joules from each charge, and the second lamp can now only get 2.5 joules from each charge. The EMF was 5 volts, and we have 2.5 volts across this lamp, and 2.5 volts across this lamp. So in a series circuit, the EMF is equal to the sum of the potential differences. Label them E, V1 and V2, and so E equals V1 plus V2. So that's quite a lot of material, and it is a tricky topic anyway, potential difference, but try to lay it out clearly. We know that the potential difference is the work done per unit charge, and if we're talking about a cell, when we think of it as the EMF, is the work done per unit charge. If we're trying to measure the potential difference, we need to measure 2 places so we can get the difference. So we place the voltmeter across the component. And in a parallel circuit, the EMF, E equals V1 equals V2. But in a series circuit, E equals V1 plus V2.